Okay, so we have discussed that when we use delimiter, we face a problem like this is the frame, this is the end delimiter, this is the data, and this is the SFD. What happened ki when what happened with ED matches with the data? Okay, this is a disadvantage we face in end delimiter. Again, how it will know that when it has to stop, it will read the data half and it will stop. So there are two ways we can handle this. The first one is character stuffing, okay, and the second one is bit stuffing. So I will explain what it is. In character stuffing, what it was like, when it was said that when the problem arrived, then that the data was everything from the keyboard, okay. And so what if we do, we add, if we have a end delimiter which is not from the keyboard, then it will be easy and it will never match, okay. Let's say the dollar was never the part of the keyboard, okay. So if the end delimiter is a dollar, then it will never like collide, it will always read the whole data. But what happened, but eventually day by day everything came on the keyboard, so everything is on the keyboard. Now what we do, if there is a data, okay, so for the end delimiter we use dollar with null, okay. This if this receiver sees this, it will automatically remove it, okay. That's then how, when there's a part dollar in the data, then it will match, and this part is not there, it will read the whole data. Suppose if data also contain dollar and null, then also we add null after the dollar. That is how character stuffing work, but it's not used wisely because it's not that much good. That is why, and it's kind of takes very costly. That is why we use bit stuffing. What bit stuffing do, suppose there is a data, okay, and there is an end delimiter, okay. After this one bit it will matches and it will stop, okay. So what we do, we stuff a bit between the data, okay. Let's say we have a data and there is an end delimiter also same, okay. So we stuff a bit between the data. There are three places. Now the question is where we will stuff, okay. I will tell you in the end. So what we do, the sender duty is to and insert a bit where we'll use C part in the end of the data, and the receiver, what it does, its duty is to remove the, it understand that when it sees this, is think that yes, the sender has done bit stuffing and inserted a bit here, and it will remove a data. So it removes, okay. Now this is the original data we have received. And even if the data, if what the problem is that ki, what if the data looks like this, then also the receiver will remove it. So what we do, even if the data look like this, then also the sender add extra bit between that, and the receiver duty is to remove the extra bit, then we got the original data. This is what bit stuffing is. So my question was, the why did we used like inserted here, why can't we insert here or here? So the problem is the probability of getting 0 1 is very high in the data. 0 1 is are everywhere, okay, and probability of 0 1 1 is also very high, but the the probability of 0 1 1 1 is kind of not very high. We rarely, not really, but it's not, we can be found everywhere. That is why we always place at the end of the last bit, just before the last bit we end the 0. The sender duty is to add the extra bit and the receiver duty is to remove it. This is what bit stuffing is.